Great. I forgot to turn on the mic. Oh, okay, great. So sorry, Simmers. I think I'm back, and now, where am I now? So yeah, which tokenizer I would know to use, right? Well, you don't have to know which tokenizer to use. Firstly, you need to know, I'm gonna use bird, right? I'm gonna use bird. Then uh, you just do something simple like this, right? Auto tokenizer dot pre-train dot from pre-train. Let's say bird. There's something like base in case we're gonna include, right? Tokenizer, right? So if you know already that you're gonna use a model bird, then you just use the tokenizer call from the big model bird. And then the next sentence you can do is tokenizer. Chucky is flying. What? Flying what? Flying at AIT. Right? And then you print the results, you will know how they tokenize. So what is the essence here? The essence is, in theory, there are many ways to tokenize, but in practice, there's almost nothing to worry about, because Huggingface or whatever library already handle all the tokenization algorithms. If you use BERT, they will automatically apply the tokenizer of BERT. If you use GPT, they will automatically tokenize such that GPT will expect that thing, right? So automatically they will be done for you, right? So that is the idea. But today lectures, I want to teach you like the real mechanisms how we tokenize, which is not necessary for those who just care about making stuff. But I think that if you truly want to know, understand, you need to study today's lesson, right? So that is the rough idea about tokenization, right? So now, by the way, for those Zoomers, you missed the beginning, don't worry, you did not miss anything, all right? Because just preview. So now, where are we? We are actually here. We come back here, right? And you may say that why you start to now talk about tokenization? Because this Wednesday, I will talk about an idea called pre-trained models. And all pre-trained models, including ChatGPT, whatever, use tokenization, right? So today is a very important lesson that you know how they tokenize, right? But again, I have to stress, because there are two types of people in this class. One that doesn't care anything, they just want to code and make something. Another type is they want to know everything. So the today class is more relevant to like a deep understanding how tokenization is made, right? But you don't have to actually know if you just care about coding. Um, so we have to first understand, why do we need to have subword tokenization, not only uh, word tokenization. For example, I have something like had and learn, I can map to the vocab that I have already. But if I have something like tasty, in which young people like us, like me and you, like to type, right? Tasty, right? It will map to ang, correct? And if you have something like, I think this is learn, right? Then it will also be ang. And what is this? Transfer form verify, right? It also will be ang. So if we tokenize word based on full word, there will be a lot of ang. Do you guys understand? If we fully tokenize every word as word, there will be a lot of unknown. So scientists think like, how do we actually minimize that, right? How do we actually minimize that? Well, if we treat this as a subword, maybe there's no Maybe we think that, oh, this is a very common subword, right? And this is another common subword, right? And we have embeddings for this one. And we also have embedding for this one, right? And treat them as two separate words instead of the same word. In that case, when we find something like this, we don't have like a lot of how about this one? Well, it's not easy, but definitely ty has some meaning, right? Ty is always something related to adjective, right? Like ty. What word use ty? Tasty, fruity, right? Nicey, there's nicey. Huh? Nasty, yeah. And yeah, I don't know. So many tt, right? So there must be some meaning here, right? So we can chop the word so that we can chop this word into embedding, right? Oh, this one is cannot fix. You cannot fix this. It's basically you cannot fix this, right? So there's no way out here. But anyway, I hope you understand the motivation behind subword tokenization. And the main motivation is mitigate unknown, right? So that is like the main motivation of subword tokenization. Great. Any questions? You got it? You got the motivation? Okay. So if anyone asks you why do we need to tokenize subword, this is the main reason. Now, you may have a question now. How do we chop the word, right? How do we chop the word? You may say checky, it doesn't make sense. Maybe trans is a good word, right? And form is another word, right? You not correct. Transform is not one word, it's two words. So what is the right way to chop the word? What is the right way to say this is a subword that I must have a dedicated embedding? This comes to the tree algorithm. How to chop into subword. This comes to the three algorithms. Three algorithms that I'm gonna teach you, right? And I only have like three main slides. And today you're gonna just do hands-on how to do it. No, I don't need to talk about this. And now let's talk about the main three algorithms. Firstly is byte pair encoding. This is very important one because you guys know GPT, right? GPT 1, 2, 3, 4. And also Mistral. Anyone know Mistral? Is probably one of the, this guy is from US, right? I think this guy is from Europe, right? And currently it's like the main competitor if you don't realize. So Mistral is very, very strong and they have a lot of money. Llama is from who? Anyone remember? Facebook, Meta, right? It's from Meta. I don't remember this too, but this is mainly for summarization. And this is basically bird with small layers. But by the way, I haven't teach you pre-trained models. So you don't know and you don't understand any of this, right? But mainly I want to tell you anything that is you can see that the main big guy used byte pair encoding. Okay? So you can understand, oh, this guy used byte pair encoding. How about word piece? WordPit is by Bird and this still Bird. They are by Google. And so maybe just to give you an idea, because you guys still haven't learned yet, all this is for decoding. If you don't see that, right? They are all language model, right? They are all decoding model, and they are language model. This one is mostly encoder model, right? That is only encoding some meaning. But if you don't understand, don't worry, because today is not the main thing. I would not teach you this thing yet. I will teach you this Wednesday. And the last one we're gonna have is unigram, all right? And the one that is very popular is T5, right? I think T5 is the main one. Multilingual bot is also very popular, right? So these are the three algorithms. Now, for those who like to code a lot, who really like to code, you come here, okay? I have prepared the code from scratch. How do you code all of this from scratch? Should you use this code for your thesis or for your project? No, okay? This is for learning, okay? So you should never use my code for real training, okay? But this is only for learning. Okay? So later on, if we have time, I will open and show you a little bit. Okay, now done on BPE, okay? Are you guys ready? And today you guys prepare some pen and paper, okay? No need computers. So you can try today, okay? Because here, there's an exercise, and we can do it together. Yep. So let's say I have a unique words. Okay, 5 unique words in the corpus. Okay. So you can imagine that the corpus contains so many, like 1 million words, but here I only have 5. So first you initialize a base vocabulary. And what is a base vocabulary? It's basically each of the characters. And you treat them as a subword. B, G, H, N, P, S, U, right? Those are all the characters in these 5 words. Okay. And then the next step, so far so good, right? So far so good. Yeah. And then add new tokens until the desired vocabulary size is reached by learning how do we merge. So this is a given. This is given. So I count in the corpus. Oh, this word happens 10 times, okay? This word happens 5 times. This word happened 12 times. This word 4 times. This word 5 times, okay? So A is a very nothing. You just count. All right. So now you can split each of the word into the vocabularies from this vocabulary, right? So HUG is 10. Okay, so nothing is just HUG, right? Each of the characters. Where does each of the characters come from? It's come from 2. The reason why is like, Chucky, why you need to do this? Because it can be mind level characters, right? So it can be something like some characters that you never see in the world, like this. I don't know how this look like, right? So that's why. And then PUG is 5, PUN is 12, PUN is 4, and HUGS is 5. Okay. So far so good, right? So far so good. The next thing we do is now we look at each pair. All right. You check, but you believe. If you believe me, you just believe me that UG, U and G together happens in 4 of this 20 times. The highest is UG. You can, I will give you like 2 minutes. You scan any other 2 characters that happen to be together. Yeah, more than 20 times. U and what? UN. Okay, so let me count UN. So UN is 12 and UN is 4 and then U 16, right? Yeah, 16. U what? Any other that is higher than 20? Okay, so it's simply count, okay? And you find that UG 10 plus 5 plus 5, right? And you got 20, right? So for those who don't see, this is 10 plus 5 plus 5. So now, based on the highest frequency, we believe that this 2 word is a very good subword, correct? Because they're always together. They are always together. By the way, when I say together, it must be next to each other. Understood? Not just if U and G is like 1 characters apart, they are not. They should be stick together. Understood? They should stick together, then count as 1. Okay? So this is if you're confused, but it makes sense, right? If you want to make a subword, they must be stick together, not 1 characters apart. So now we found that this guy is the highest, so it makes sense to merge them. We merge them. So now we merge them. Okay? And in here, the base vocabulary will change. This guy would be something like this. Okay? So your base vocabulary change. Now we don't have a word called U and G, okay? We only have a word called UG. Yes. So yeah, so here the vocabulary looks like this. Right. Now, based on this vocabulary, we continue. Okay, we continue. Now, the corpus become like this. H, UG 10 times, correct? You change because now you don't have UG, you have UG. And then PUG 5, PUN 12, BUN 4, HUG S 5. So everything good, right? So I think to enhance the understanding, why not you do this one more time? So based on this, you do one more time and tell me what is the next vocabulary. And I will ask someone to come up and tell me the solution. Yeah. You continue from here. You guys, everyone, continue from here. Do one more time. Yeah. Do one more time. I will pause the recording so that the people who watch this video no need to wait for us. But all right, so now we come back. We know that UN has the highest frequency. So vocab is basically B, G, H, and P S U UG and UN. Yep. Yep. I forgot N. Is this N? No. Yeah. All right. Okay, great. And then once you do that, what is the next corpus? The corpus will become now H U G N, and then the P U G 5 and P U N 12, and then the B U N B U N 4, and then the H. This is still the same. H U G S 5. All right. So that is byte pair encoding. So hopefully now you understand byte pair encoding. If there's one thing that actually I oversimplify, is that in byte pair encoding they add this as the space. Okay. This is something that I did not keep in this exercise, but I think is very trivial, right? The reason why I talk about this is because some students, like when you tokenize, you get this G hat and you're like, what? And then they just stop using byte pair encoding. Actually, no, it's just space. Okay, great. So now we understand byte pair encoding. So now you understand the purpose, right? This is the purpose to construct software, meaningful software. Yep. You may say, why not use dictionary? Because there's no dictionary. You cannot use dictionary to say this is a subword, UG, right? We don't even know what is UG, but by using this greedy algorithm, we hope that we can construct 50,000 or 100,000 most meaningful subword, right? With the highest frequency. Yep.
If you take UG, it will be 10, UG5, and then UG5. Like, first we are going to pair it up, or we can count that.
Can you please say again?
Like, here we have UG, that is 10. We are counting the words.
Yeah.
So then again
UG 5.
5, and then again, so it will be 20. So we should merge this first.
No, UG, you cannot, you mean UG is 10, UG is 5, and UG is 5, right? That is 20, right? But we need to merge with someone. We need to merge with someone. So you need to see, is it good to merge HUG? HUG is 10, and here HUG is 5, right? So 15, yeah. So you need to look to not you only UG. Okay, great. Okay. Now, word piece. So this is also a very important, guys, because Word use this, and it's by Google, right? So if Google is very smart, then we should study them, right? Who made who? By the way, I think it's important that you guys know all of this. Who come up with byte pair encoding? Which company come up with byte pair encoding? Give you some hint. It's the same guy that come up with GPT. OpenAI. Okay, so byte pair encoding is by OpenAI, right? If that is not clear yet, but WordPress is by by the way, I have to just pause a little bit and say that for those, I understand that every time in the class there will be like 4 to 5 guys that cannot do just now. You just forget everything I said. Just believe me that if you just understand the feeling, it's enough already. When you code, you just say tokenize auto tokenizer from pre-train this model finished already, right? But if you understand this, is few. I don't know. From my experience, the students that I supervise and they can do very well in thesis or in my company is the one that understand this. I don't know why. I don't really know why. I mean, this is not related to coding. Eh? It's only theory. But what I understand, and we can say that, is the best students I have in my company and in my thesis is usually the one that I actually understand all this. I don't know why, but that is the case. But anyway, let us go to word quiz, right? So if you understand that one, then this one is easy, right? Now you got this chop, okay? Which means that it comes from some word in the beginning, all right? But anyway, let us do this, right? So we have a unique word. Sorry, talk, fun, bun, talks. Oh, that is tough. And then, so this is given. All right, so this is given, right? So let's say we have H, UG10, PUG5, PUN4, BUN4, SUGS5, okay? And I will say again, what this means is something in the front, something previously in front. All right, so that is what it is. And based on this, we can come up with a vocabulary that our vocabulary is nothing but this. Is this. And you can see that it's very interesting. In bird, you have a essence that B is the only one that can in the beginning, right? And H and P are the only three guys that can be in the front. The rest of the guy is in the back. So this is something that is a little bit special about word piece, right? Okay, so this A is quite easy. Now the next one is when I see equations, I feel a little bit threatened. Score equal to frequency of pair. Okay, frequency of pair divided by frequency of the first element multiplied with frequency of the second element. So in this score, you may say that, oh, tricky. The most frequent pair is UG, right? Correct. So this one is 10. This one is 5. And where's another one? Oh, here. So this is 20, right? This is 20. But this is not something that WordPress will think. What WordPress will say, hey, but you also need to normalize it, right? So how do we actually normalize it? Well, we do like this. Okay, let me delete everything. Everything is getting messy. So UG here is equal to 20, right? Frequency of pair. But frequency of the first element is U. So you count. U is 10, U is 5, and U is 12, right? And how much is that? U is 5. Yep. Where did I? Oh, here. So how much total? 36. Yep. 36. And frequency of the second pair? 20. Then this one is not correct. 20. So this is 10, 5, and 5, right? Right. So that is 20. Oh, so how much is this? 20 divided by 36 times 20 is 1 over 36, right? So then we got 1 over 36. So now, this is not the highest, right? This is not the highest. You go and find which one is the highest, but I already tell you the highest. The highest is GS. The highest is GS. All right. So I will pause a little bit, but I will tell you that the answer is 1 divided by 20. Can you pause a little bit and find why GS is 1 over 20? Yeah, it's 1 over 20. Good, good. Okay, you take your time. All right. So now, GS, what is the frequency of the pair? 5, right? So, oh my goodness, I need to walk. GS, yeah, it's here, right? 5, right? So GS equal to 5. How about G? 20? Okay, you guys know. So G equal to 20 and multiply with S is equal to 5. Okay, so 5 divided by 20 times 5 is 1 over 20, right? And you can do for all, okay? And finally, you will realize that this guy is the highest, okay? And then based on that, you now have the vocabulary with the GS here. And then also in the corpus, this is merge. This is not merge. Now you do, I want you to do one more time. And after this, how about we take a break, okay? Oh, it's so difficult. I mean, how you have to check every path. Oh, I will rely on you guys. You got the answer? I will copy you. Exactly, exactly. That's it. Yeah. So Pirun Rat asked a quick question. I will say that again. Huh? Sorry?
If there is a
So Deepali asked if there's a tie, don't worry. Whichever comes first, it will be with the winner. Yeah, you can imagine in the coding, if this guy win, then whichever come in the first in the list, it will be the winner. Because in the coding, it will be like that, right? Yeah. So tie, just pick anyone is okay. There's a tie? You think? UG, UG and UN. 1 by 36. Okay. Okay. Let's wait. Maybe some other people have 1 over 30. Maybe. Huh? BU? Okay. Okay. So everything is 1 by 36? Okay. You sure? Oh, so unlucky. Great. Nothing higher than that? Nothing? Anyone can come up with higher than 1 over 36? Okay. Then according to the whole class, I think everyone conclude that any word can be merged, right? Because they have the same like 1 over 36. So let's say this can be merged, right? UG, if you merge this one, then you will have UG, right? And you also always need to take the sharp together, okay? Because we know that U comes from the beginning. So when you merge UG, you should also bring the sharp. And then this will be merged. This will be merged. And this, no, you cannot merge this one. That's it, okay? So that would be the next round of algorithm. Okay, great. So I think I have talked for a couple minutes already. Why not we take a break and we come back, okay? So, sorry. And give me 1 second. He's sick, yeah. Okay. So yeah, this is that, and there are some people who all like understand 99%, but just if you're confused, I think you just remember one. All this idea are actually very simple. That is, you create subword based on frequency. Finish. Like very frequent word becomes subword. Finish. And all this technique, if you make you confused, you just forget about it. Okay. But the main principle is highest frequency become the subword, right? And vocabulary is the real output, right? Vocabulary is the real output of this thing. This is the subword, right? This is the subword. Yep. The corpus is for training. The corpus is for training this vocabulary. So this corpus you will keep merge until there's nothing to merge, then you finish, right? So usually you cannot finish because the corpus will be like so many. So corpus is mainly for training the vocab, but the real output of this algorithm is the vocab. Okay, so that is something to clarify. Great. So I have only one algorithm. We can relax a little bit and maybe we can show some code. Again, if you are not comfortable with all this, you don't need to worry. You just get a feeling, okay? In the code, you just code one line, finish. Yep. Okay, great. I would, he will also not ask you in the quiz. We will never ask this kind of thing in the quiz because it's something that is mostly theoretical. Yep. So now unigram. This guy is a little bit difficult, okay? And I don't even remember what did I write here. So I also need to learn with you guys. I wrote this like last year, and this is the first time I was I see this again. Every year I teach one time, and then every time I forgot. But anyway, let's try to learn this together. Yep. So the corpus is this. All right. But dictionary is a little bit different. This guy is a little bit headache. In Unigram, you start from all possible vocabulary, and then you slowly delete. All right. So in the dictionary, in Unigram, you start with all possible combinations. Okay. So basically factorial, right? Factorial of unique characters. So H, U, G, S, U, U, G, P, P, U, P, N, U, N, P, P, U, S. You understand? It's all the possible combination. Yep. All the possible combination of all this guy, right? But there's only but the combination of the full word is not here. Yeah. So that is something that we have to notice. So what is the idea? Unicam start with a big vocabulary and then remove tokens. So we remove instead of add, we remove, right? At each step of the training, this guy will compute a loss over the corpus given the current vocabulary. So the idea is like there's some loss that you compute and see whether which subword we should delete. And by the way, you may wonder like where's the sharp? This guy don't use sharp. Okay, there are no sharp. And then the algorithm computes how much the overall loss would increase if that symbol is removed. And the one that increased the least will be the one that will be gone. That means this guy is no use. Do you understand? Right? So if I say, if my current loss is, let's say 2.8, right? Right? Maybe if I remove this guy, delete BU, my loss become 2.9. Okay? Okay? If I delete, let's say I just randomly, if I delete SUG, my loss become 3.0. Which one is more important, BU or SUG? Which one is more important? SUG, right? Because when you delete this guy, your loss increased by 2, right? So this guy you should delete. But you don't do only 2, you do all. Understand? You do for all and see which one increase the least here. Increase the least. You're not understand, right? Increase the least. That one you delete because that guy no use. Yeah, not no use. I mean, everything is useful, but less useful. Yeah. Okay, so that is the idea. But how do we compute the loss? How? This is something that we have to understand. All right. Okay, great. So you guys are okay? Okay. Okay. Okay, great. Now, so now we have frequency of each subword, right? So this is given, right? H is 15, right? So, and U is 36, G is 20, HU is 15, UG is 20. You guys can count, and that should be correct, I think. Yeah, let's check. SUG is 15, SUG is 10, and SUG is 5, right? So HUG 50, yeah. So seems like I'm doing correctly, okay? If there's any mistake, it's probably mistake from Chucky, okay? Because Chucky may calculate wrongly, okay? But you understand that this is given from this corpus. Yep. Okay. Okay, I read my next sentence already. Now we let's understand a little bit first. Okay, let's understand the basic way to calculate the probability. Yeah. So let us look at here. To tokenize a given word, let's say PUG. How many ways we can tokenize this guy? I mean, when I say tokenize, means chop into subword, okay? How many ways we can chop? Oh, this guy, we can chop into 3, right? Or we can chop into P, U, and G, right? Or we can chop into P and UG, right? There are 3 ways you can chop this guy, right? Yeah. Let's check which one has the highest probability, right? So the probability of PUG is basically the product of all the probabilities. So 17 comes from the P. I should change my color. Give me 1 second. So 17 of P comes from here, right? And 210 is basically everything. And then U is 36 and G is 20. Then you got the probability. Higher, better. Higher, better. Higher, better. So now you also do the same, right? For P, U, and G, and P and UG, right? You already have all the probability here, right? In this table, right? So that you should be able to get all of this. Now I want to stop a little bit. Can you guys check? Can you guys do? Can you guys do this for me? So we already do for P. I already do for PUG for you, right? You guys go do SUG. Okay? Can you guys do? Okay, you try. You try do this 3 and tell me which guy has the highest probability. So what is the score for the first one? How much? Zero point 0.016. Correct? 1.16. Yep. And how about the second one? This guy is 0.0068. Okay. Same for the last one. Ah, I see. And this one is how much? 0.0068. I think I forgot one thing. Can you guys also help me calculate 15? I just want the whole word maybe divided by 210. How much is this? Right? Yep. So actually, I think I did some mistake here. Actually, you also need to think about maybe you don't want to chop everything, right? But anyway, based on this, for Hug, there are actually not only three choices, right? SUG, SU and G, H and UG. But there's also one possibility that you don't need to chop anything, right? This itself is a subword, right? Could also be a probability, right? So you can see that the first guy is zero, like no use, right? The second and third guy is very competitive, 6-8. But the third guy and the last guy is you don't need to chop it, right? It's much higher, right? So in this case, you know that for Hug, you don't need to chop it, right? That could be probably the right one. So let's say now you know how to do all of this. Now you got all the scores. So now these are all the scores. And you need to believe me because I already do it for you, right? So for Hug, this guy has the highest score. For Puck is this one, right? For Pun is that one. And for BU is this one. And for Hux is this one. All right. So now we need to calculate the likelihood of this probability, right? And the likelihood of this probability is let's call it the loss, right? Which is not anything but the minus log of this one, right? You may say that, Tricky, why you put a minus? Because we want to maximize this guy. We want to maximize this probability, correct? So if we want to treat it as a loss, we just put a minus, correct? Yep. And log is just to make this number stable. Okay. So nothing else, right? And you may say, where does this 10 come from? This 10. Can anyone tell me where does? Yeah, it's basically from here, right? Right. That is how many times this guy come. The reason why we need to multiply 10 is so that we understand that if this guy come often, then we need to care this guy a lot, right? If we do subword wrongly, then this guy will affect the total loss, right? So now we let's say we compute the whole loss, right? And we got 169.8. 169.8. So now the question is how do we actually work on this, right? which token we should remove, right? So currently we have which token? We have this guy, we have this guy, we have this guy, we have this guy, and we have this guy, right? So now we have to think a little bit which guys we want to delete so that we can get the highest, like the loss that is increased the least, right? So let us do this, right? Okay, okay, good. So now, let's say that I delete, let's say I want to delete this guy, okay? I want to delete this guy. I want to check where, if I delete this guy, how much loss is increased, right? So if I delete this guy, if no longer this guy appear, then I need to use the next highest guy, right? Just now, the next highest guy is this guy, correct? Correct? Just now, the next highest guy is this guy, correct? That is not 0.07, right? So let me try. If I delete this guy, and then the next guy will take in, right? So this could be the next subword, right? Possible subword. Then I calculate, if I change it, how much loss I will increase, right? So this is just simple equation that to calculate, basically now you have this and you take this out, right? Then you will see that your loss increased by 23.5, right? Then you may not know that, hey, Chucky, how do I know that this guy is the one that will increase the loss the least, right? You have to try everyone. You have to try every guy and check which one actually increase the loss the least, right? Which I will not do here, okay? Because it would take a lot of time. All right. I know I talked that one very quickly. Can you? So basically, here is a little bit confusing. So now I have A, right? And I already have all this token, right? I know that this is the way I would token. I mean subword. Yep. This is my way of subwording. But now I want to know which one should I delete, right? I need to try one by one. First of all, let me try to see what if I delete this guy, right? If I delete Huck, it means from the dictionary, this guy will be gone, right? Right? I want to try. If I delete this guy, then Huck should not be tokenized like this because there's nothing there, right? Then the next possible way is only this way. Correct? So now, how do I check whether when I delete this guy and replace with this guy, how much the increased loss is, right? So basically, I just reverse this guy and then plus the new guy, right? Now I know how much the loss is increased, and which is 23.5. So how do we do this? We just delete every guy one by one and check which guy increased the loss the least. That would be the one that give us the one that we should delete. Then we repeat the whole process again. And finally, we got the idea. So good news. Even though this guy looks very complicated, looks probably the most theoretical thing, very little people use this guy. Simply because it's overly complex and you can see that you need to compute a lot of loss, right? And you need to try a lot of things, right? So it takes too much time and people know, I don't think any like big name use this anymore, right? But it's also a good idea to understand that, hey, by one you remove and you know which one reduce the loss the least, then you increase the loss the least, then you remove that one. It's a good idea because in many NLP algorithms, they also use this idea. Okay, so that is the unique graph. All right. It's 10:35. So let me see whether I have any others. Next slide. Okay, great. So this is the last slide. So yep, thank you very much for today tokenization, and see you Wednesday on pre-trade model. Thank you. Bye-bye.